Hello everyone, you're welcome once more to NEPH, your YouTube channel where we solve our problems in math. If you're new here, you're highly welcome and do well to subscribe to this channel. I'm the tutor Mr. Okuchi, and if you don't mind, you can pause the video and attend this question solve. The first thing you want to do in math is identify what topic the problem falls in. And from what we are seeing on the board, okay, this problem is on calculus. And under calculus, we have it as what? Integration. Because this symbol is a symbol of what? Integration. Okay. So I've been able to identify the problem. So now we'll now go into the question problem. All right, so I'm going to, refresh us on some basic principles on calculus before we're able to look at the problem. So our solution, now if you're given y is equals to, let's say, ax raised to power n, or y is equals to what? X raised to power n. Let's say a is 6 and you have x raised to power n, so a is 2 and we have x, so there's a power there which is 1, all right? Or you have no coefficient before the x. How do we differentiate this? Okay, using the general method. All you need to do is this becomes the y over the x. That's differentiating y. That's what this means. Is equals to what? Now to differentiate this, okay, the power, which is n, is going to come in here to multiply the a, okay, and we'll subtract 1 from it. That will be a multiply n, so x raised to power, we'll subtract 1 from the power. As simple as that. Alright, what about this? We are still going to do the same. Of course, there's no coefficient, but the n will come down to multiply the x and we'll subtract 1 from the power. So, from this part, I can see that if I make this over 1, okay, my dy is equals to what? I have a multiply n x raised to power n minus 1. This is going to multiply this, so I have multiply the x, and 1 will multiply this. So this relationship is through which we have something like this, okay? Now the idea is we have differentiated this to get this. Okay, integration is a reverse process, okay? It's anti-differentiation, okay? So when you integrate, okay, you want to come back towards this or this. Okay, but in this case, if we are going to integrate all this, we are going to arrive at. Okay, let's check it out. Now, for me to integrate all this, all I need to do is I'm going to put this here, so which is this, and I'm also going to put it here. All right. So if I do that, this will cancel out the differential sign there, so we'll be left with just what? Y. Okay. So let's see what we have. So this will give me y is equals to. Now what about this? Now if we are to integrate this, remember we removed what? 1 from the power, and we brought down the power to multiply this. Now when you are integrating, all you need to do is you have to add 1 back, the one you removed. So I have all this as a multiply n x raised to power n minus 1. So we are going to add 1 back. And for integration, okay, you divide. For differentiation, we use the power to multiply, but for integration, you use this whole power after adding the 1 to divide. So I have n minus 1 plus 1 to divide. So let's quickly simplify that and see what we are going to get. So by integration, when you solve this, you arrive back to this. So let's see, this will give us y is equals to a multiply n, so x, okay, that's n minus 1 plus 1 divided by n minus 1 plus 1. So which will give us y is equals minus 1 plus 1 is 0, so I have a multiply n x raised to power n plus 0, which is still n, Divide by, so all this is also going to give us n, because minus 1 plus 1 is 0, so which is n. Now these will cancel out this, so we are left with a multiply x raised to power n, which we have here initially. So with this, okay, we can now be able to solve the equation we have on the board without wasting much of our time. So this equation becomes, okay, I'm going to say differentiating 6x squared dx minus differentiating 2x dx. Alright? Now when we do all this, we are going to bring these two values here, 2 and 1. Now what are those two values? They are called our limits. We have this as the upper limit and this as the lower limit. Okay, so let's differentiate this. Then we'll now use the upper and lower limits to solve further. So to differentiate this, remember, I'm going to say 6x raised to power 2. Rather, to integrate this, I'm going to say 6x raised to power 2, and we're going to add 1 and bring all this down. Okay, so we have integrated this. Now for this has the power of 1, so minus have 2x raised to power 1 plus 1 divided by 1 plus 1. Alright? So that gives us the integral of 2x. Alright? So we don't have to forget to put our what limits. The upper limit, which is 2, and the lower limit, which is 1. Alright? Because we are going to use it. So this will give us what? This will further give us 6x raised to the power of 2 plus 1 is 3, divided by 2 plus 1 here is 3, minus, this will be 2x raised to the power of 1 plus 1 is 2, divided by 1 plus 1 is 2. Okay? So solving that further, we are still going to put our limits, which is 2 and 1. So these will cancel out this I'm saying is 2 times. So we have this as 2 times x raised to the power of 3 minus. These will cancel out this 1, 1. So we are left with just 1 times x, which is x raised to the power of 2. And we'll still put our limits. Now at this point, we are now going to use our limits. The idea of these limits, the upper and the lower limit, is you want to input the upper limit here first. So upper limit, okay, here as x. So x becomes 2 minus, you now put the what? The lower limit. Okay, so that gives us the solution to this problem. So let's quickly put that and see what we are going to get. So I'm going to start with the upper limit, which is 2. So I have 2. I'm going to put 2 here, so which is 2 raised to the power of 3 minus, okay, x is 2, so 2 raised to the power of 2. So that is my upper limit minus. Now we are going to look at the lower limit. So I'm going to put x as 1 inside this same expression. So that will give us 2 multiply 1 raised to the power of 3 minus what? 1 raised to the power of what? 2. So we made use of the upper limit and the lower limit. So let's see what the difference of the upper and the lower limit is going to be. So this will give us 2 raised to the power of 3 means 8, because 2 times 2 times 2 is 8, minus 2 raised to the power of 2 means 4, because 2 times 2 is 4, minus. So 2, 1 raised to the power of 3 is still 1, 1 raised to the power of 2 is still 1. Alright, so from this we can now finish up. Alright, so our upper limit is going to give us 2 times 8 is 16, minus 4, minus 2 times 1 is 2, so 2 minus 1. So 16 minus 4 is going to give us what? It's going to give us 12. minus 2 minus 1 is going to give us 1. So 12 minus 1 is going to give us what? 11. So 11 actually is the solution to this problem. Alright guys, thank you guys for watching this video. Give a like button and subscribe to the YouTube channel and send this video to somebody who may be of help. I'll see you guys in my next video. Bye.